we will discuss truth tables. So, our goal for today is to determine the truth values of certain propositions. So, let us first have a short review. So, we have here the connective, the symbol, and the type of statement. So, for the connective and, we use this symbol, and this means conjunction, or is symbolized by this symbol, or this is also called a disjunction. Not is symbolized by this symbol. This represents negation. The if-then statement is symbolized by this arrow. This is also called a conditional. And the if and only if statement is symbolized by this double-sided arrow, or we also call it a biconditional. Now take note when we say propositions, these are declarative sentences or a declarative sentence that can be classified as either true or false, but take note it could never be both. So the statement could only be true or it could only be false. So we have two types of proposition. The first one is a simple proposition. So a simple proposition is a proposition that conveys one thought with no connecting words. So you cannot find connectives such as and, or, if and only if, and the if then in a simple proposition. The other kind of proposition is a compound proposition. So a compound proposition contains two or more simple propositions that are put together using connective words like and, or. We have the if and then, and we have the if and only if. Now, a truth table is a table that summarizes all the possible combinations of the truth values of propositions. So, you are summarizing all the possibilities of whether the statement could be true or false in a truth table. So an example of a truth table is this one. Okay, so we will learn how to complete this table later in this lesson. Now, as what I have said or as what we have reviewed earlier, we will discuss 5 propositions. Here we have the conjunction, disjunction, negation, conditional, and the biconditional. So we will start off first with the conjunction. So a conjunction uses the connective and, which is symbolized by this upside down V. Okay, so it looks like an upside down V. So this implies that the idea is the idea of both, meaning two statements are connected or it is both correct. So if we represent the propositions as P and Q, so the first proposition is P and the second proposition is Q, so a conjunction will be represented by this symbol. So you read the symbol as P and Q. So P and Q will only be true when both P and Q are true. So in a truth table, P and Q will only be true if both P and Q are true. Example. So we have here a table. We have here P. Then we have here Q. So these are all the possible combinations that P and Q could have in their truth value. So P and Q could either be both true, P could be true, and Q could be false. P could be false and Q could be true, and P and Q could be both false. So P and Q will have the following truth value. So again, P and Q will only be true if both P and Q are true. So here we look at P and we look at the truth value of Q. So since both P and Q are true according to our rule, so P and Q here will be true because both P and Q are true. Here, P is true and Q is false. So P and Q will have a truth value of false because not both P and Q are true. Q here is false, therefore P and Q will have a truth value of false. Next, P is false and Q is true, so therefore P and Q will also be false. And P is false, Q is also false, so truth value here is false. Again, a conjunction P and Q will only be true if both P and Q are true. Get it? Now, we will move to disjunction. So, a disjunction is symbolized or is using the connective or. So, the connective or symbolized by this V shape, okay, implies the idea of either one or both. So, either one of the propositions in the compound proposition is true or both of them are true. So if we represent the propositions as P and Q, P or Q will be true when at least one statement is true. So if P is true, then the whole statement will be true. If Q is true, then the whole statement will be true. If both of them are true, then the whole statement will also be true. If both of them are false, then that's the only time that the whole statement will be false. Now, to illustrate it better, let us look at this truth table. Now, again, these are all the possible combinations of the truth values of P and Q. So, first case, P is true, Q is true. So since both of them are true, P or Q will be true. Next, P is true, Q is false. The statement P or Q will also be true because one of them is true. The next one, we have P is false, Q is true. The whole statement P or Q will still be true because one of them is still true. And the last possibility, we have P is false, Q is false. Okay, so the statement P or Q will be false because none of the statements are true. Again, the statement P or Q will be true when at least one statement is true. So P or Q or both of them will be true for this whole statement to be true. So that is again the disjunction or the proposition, the compound proposition that uses the connective or. The next one is the negation. Now, the negation of a statement or the negation of a simple proposition is symbolized by this sign. Okay? So the word not is commonly added to the original statement or the exact opposition given or this exact opposite of the situation given will make the statement a negation of the original statement. Now, for a simple proposition, the truth value of the statement is changed to its opposite. That means that when the statement is originally true, the negation of the statement will become false. If the original statement is false, then the negation of the statement will become true. Okay, to clearly illustrate this, let's have this truth table. Now, for example, we have P. Again, we are using only a simple proposition for this one. Okay, so for P, we have only two possible truth value. P could either be true or P could be false. So if P is true, not P, so you read this as not P will become false. So it's the opposite. If P is false, then the truth value of not P is the opposite of false, or that will be true. Is that clear? Okay, let's now proceed to a conditional. So, a conditional, or the if-then statement, is symbolized by an arrow pointing to the right. So if we represent the propositions as P and Q, and P implies Q, P is called the antecedent. So the first proposition is called the antecedent, and the second one is called the consequent. So the statement P implies Q, so you read this as P implies Q, so will always be true unless P is true and Q is false. Again, P implies Q will always be true unless the case is that P is true and Q is false. So to illustrate this better, we have here, again, these are all the possible truth values of P and Q. So we have here P implies Q. So if P is true and Q is true, P implies Q will be true. If P is false and Q is true, P implies Q is true. If P and Q are both false, P implies Q will still be true. Now, P implies Q will only be false if P is true, or your antecedent is true, and Q, or your consequent, is false. So the statement will be false only for this case, when the antecedent is true and the consequent is false. Clear? So the last one is the biconditional. So in a biconditional, or we also call this the if and only if statement, so the if and only if statement is symbolized by this double-sided arrow. If we represent the propositions as P and Q, P, if and only if Q, will be true when P and Q have the same truth value. In other words, P, if and only if Q, or the biconditional for P and Q, will only be true if P and Q have the same truth value. That happens when P and Q are both true, or P and Q are both false. So to illustrate this better, let's look at this table. So again, these are all the possible combinations of the truth values of P and Q. So P is true and Q is true. P, if and only if Q, will be true because they have the same truth value. Next, when P is true and when Q is false, P, if and only if Q, will be false because they don't have the same truth value. When P is false and Q is true, the same will be false because again, they don't have the same truth value. And when P is false and Q is false, P, if and only if Q, will be true because P and Q have the same truth value. Okay, get it? Okay, let's have a short recap. Or the conjunction or the proposition that uses the connective and. So that will only be true when both P and Q are true. Next, for a disjunction or the compound proposition that uses the connective or. So that will only be true when at least one statement is true. Now, for the negation, or for a simple proposition that uses the word not, so the negation changes the truth value of the statement to its opposite. So when the original statement is true, the negation becomes false, and vice versa. For the conditional, or otherwise called the if-then statement, or also called the if-then statement, so a conditional will always be true unless P is Q and true is false. For a biconditional, or the if and only if statement, so the biconditional will be true when P and Q have the same truth value. Okay, now let's practice your skills in the following exercises. So first, we will construct a table of values for P and not P. Again, P and not P. For P and not P, so we will have the basic P. So we will have to determine the truth value for not P. So if P is true, not P, okay, is the negation. So we will change the truth value to its opposite. So true becomes false, and false will become true. Now, since this symbol is for and or a conjunction, so take note, remember that the conjunction will only be true when both P and Q are true. So P and not P. So we have here true, false. So P and not P will be false, and for the second situation, that's P is false, not P is true. P and not P will be false. So for both cases, P and not P is false. Now, we have here a sample statement. So to make it more relevant. So let's say P stands for the statement, I will be a seafarer. So not P, or the negation of P, will be I will not be a seafarer. That's the opposite of your first statement. So P and not P will be I will be a seafarer and I will not be a seafarer. So this makes it clear why P and not P for both cases is false. So next sample. We're going to construct a table for P or not Q. This time we have P and not Q. Again, we have here all the possible values or the possible truth values for P and Q. So first, let us identify the column for not Q. So let's look at Q, and we will identify the column for not Q. If Q is true, not Q will be false. If Q is false, not Q will be true. If Q is true, not Q will be false. If Q is false, not Q will be true. Now, take note, P or not Q is a disjunction. Okay, so take note the disjunction will only be true when at least one of the statement is true. This time, since we're looking for P or not Q, we will only look at the first and the third column because those are the columns for P or not Q. So take note, again, remember, this disjunction will only be true when at least one of the statement is true. So P or not Q, that's true false. So one of them is true, so the whole statement will be true. So P and not Q, or P or not Q, that's true, true. So both of them are true, so the whole statement will be true. Next, we have false, false. Since both of them are false, the whole statement will be false. And false, true. Since one of them is true, the whole statement will be true. We'll have a sample statement. Ali is 17 years old. That will represent P. Let's say Q stands for Ali is a senior high school student. So not Q is the negation of the Q statement. So that will be Ali is not a senior high school student. So in sentences or using this example, P or not Q will be Ali is 17 years old or is not a senior high school student. Let's now proceed to the next example. We will construct a table of values for not P if and only if Q. So that's a biconditional and a negation. Again, we need not P and not P if and only if Q. So here are all the possible combinations for P and Q. Not P, we will get the negation. Again, the negation changes the truth value of the statement to its opposite. So P is true, not P will be false. Again, here, P is true. Again, not P will be false. And not P will be true since P is false for both cases here. Now, take note for a biconditional, this will only be true when P and Q have the same truth value. So we will only look at not P and Q. So we'll only look at these two columns. Not P if and only if Q. So we have here false, true. So they don't have the same truth value, so the whole statement will be false. We have false, false. Both of them are false, so the whole statement will be true. So here we have true, true. Okay, so they have the same truth value, so the whole statement will be true. Next, we have true, false. So the whole statement will be false. Okay, here's a sample statement. Let's say P is represented by he failed the subject, and Q is represented by he passed all the quizzes and other tasks. Not P will be the negation or the opposite of P, which is he did not fail the subject. Therefore, we have here not P if and only if Q will be he did not fail the subject if and only if he passed all the quizzes and other tasks. Okay, and let's now have our last example. We're going to construct a table of values for P implies not Q. Again, we take all the possible combinations of the truth values of P and Q. So we need here not Q. So not Q, so that's a negation. So that's the opposite of the truth value of Q. So first, Q is true, so not Q is false. Next, Q is false, so not Q is true. Q is true, so not Q will be false. And when Q is false, not Q will be true. So, P implies not Q is a conditional. So, if we're dealing with a conditional, it will always be true unless P is true and Q is false. So we have P implies not Q. So we're only going to look at the first and the third column. So, and we will use the rule for the conditional. So it will all be true unless P is true and Q is false. So first, P is true, Q is false. That means P implies not Q is false. Next, P is true, not Q is true. So the whole statement will be true. P is false, not Q is false. So the whole statement will be true. And lastly, P is false, not Q is true. So the whole statement will be true. All clear?